Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 11 on the Arduino. And so if you haven't done the earlier lessons, you probably want to go back and do those because each lesson will build on the earlier ones. And in the last few lessons, one of the things that we learned very recently, how to read voltages from a potentiometer, how we can come up and create a voltage divider on a potentiometer, and then read the value from the potentiometer on the Arduino. And then in the lesson before that, we saw how we could work with an LED, how we could control the LED from the Arduino. And basically what we're going to be doing today is we're going to be combining those things into one project where basically what we want to do is create a dimmable LED where the brightness of this LED is set by the position of the potentiometer. So if you have the potentiometer all the way to the left, you want the LED to be off, and if you have the potentiometer all the way to the right, you want the LED to be at full brightness, and then you want it to scale all the values in between very smoothly. This circuit should not be a surprise to you. This is just basically combining two of the circuits that we did in earlier projects. And so let's look at this and see if we can just get a quick recap. You've built these before, but just remember when you're using an LED that the long leg of the LED always needs to be pointing towards the voltage supply. Remember, we never use an LED without using a current limiting resistor. We're using the 330 ohm resistor, and then here we are using the potentiometer. Okay. Just a reminder that I'm using the components from the SparkFun Inventor Kit. All of these lessons are going to be using components from the SparkFun Inventor Kit, and if you look at my website under this lesson, I can give you a link of where you can pick that up, or you can just go in and you can basically do this with some of your own components. But I think the SparkFun Inventor Kit is an excellent value. If you don't have one, I recommend that you run out and get one. Okay, well let's look a little bit at this circuit and see some of the stuff that we're going to have to do. It's pretty easy programming. There's a little bit of math we have to do because we got to remember when we do an analog read, remember we're reading voltages between 0 and 5 volts, but we don't read the number 5. When we do an analog read, the values that we read scale between what two values? Okay, do you remember? They scale between 0 and 1023. So if we have a real-world voltage here that we are reading of 5 volts, the number that the Arduino will read is the number 1023. So 1023 corresponds to 5 volts. Reading a value of 0 corresponds to 0, and they scale in between there. 0 to 1023 reads means 0 to 5 volts, and you can scale things with a linear equation. Similarly, when we're doing analog writes, the numbers scale between 0 and 255. So if you want to write 0, you write the value 0. If you want to write 5 volts, you write the number 255. If you wanted to write 2.5 volts, you would write 255 divided by 2. So the numbers between 0 and 5 scale to the numbers that you would write between 0 and 255. And so basically what you're going to have to do is you're going to have to take numbers that are between 0 and 1023 that you're reading for the real world of 0 and 5 volts. You're going to have to scale those to numbers between 0 and 255 so that you'll be writing numbers between 0 and 5 volts. And so you got to take the numbers that you're reading 0 to 1023, and you got to map those onto the numbers 0 to 255. And we do that, hopefully you would think right off the bat that we've done this in an earlier lesson just with some different examples. But what we're going to want to do is we're going to want to use a linear equation. And anytime we're going to do this, just do this every time and just set up your graph because it's good practice about what you've learned in math class. But basically, to calculate these right values that we want to put to this LED, we're going to calculate the right values. We've got to think about down here on the horizontal axis, what numbers are we reading? Well, we're reading numbers between 0 and 1023. Those are our analog read values. Those are the numbers that we're reading off of the potentiometer. But what we want to do is we want to write a voltage to the LED between 0 and 5 volts, which would mean we would need to analog write values between 0 and 255. And we've got to map all the numbers in between. Well, what we need to do is to get the equation of that line, we need 2 points. Well, what's the first point we know? Well, we know that if we want to write 0 volts, we would write 0. So 0 corresponds to 0. The point 0, 0 is 1 point. The other point is that if we read a value at the complete other end of the scale, if we read a value of 1023, we're going to want to write a value of 255. So the second point is 1023, 255. So now I have 2 points, and if I have 2 points, I can write the equation of a line. The first thing we need to do is we need to find the slope. Well, the slope, which we usually say is m in math class, is y2 minus y1 over x2 minus x1. Well, I like to make things where I get positive numbers. You can pick either point as x2 or, as the second point or the first point. But I'm going to say that y2 is 255 minus y1 is 0 over x2, which is 1023, over x1, which is 0. I ended up with y2 minus y1 over x2 minus x1 is going to be 255 minus 0 over 1023 minus 0. And then that comes out to be 255 over 1023. So the slope is 255 over 1023. Well, the point slope form of a line is y minus y1 is equal to m onto x minus x1. You can pick either one of these points. It'll be easier if we pick this one. You get the same results, but it's easier to pick the one that's 0, 0. So I have y minus 0 is equal to 255 over 1023, the slope, onto x minus 0. So that's just saying y minus y1 is m onto x minus x1. We calculated m. We put it here. Okay, and we use the point 0, 0. So we end up with y minus 0 is equal to 255 over 1023 onto x minus 0. And then that just comes out to y is equal to 255 over 1023 times x. That's the equation of this line. Well, now that we've done that, let's go back and put what we're actually doing. Y was analog write values, and x was analog read values, so we get that the write value that we want to write to the LED is equal to 255 divided by 1023 times the read value. So we take the read value off of the potentiometer. We take the read value that we get off of the potentiometer. We multiply by 255 divided by 1023, and that gives you the right value, the value that you want to put out to pin 9 to turn the LED on. And if we use that equation, then we're going to smoothly transition from 0 to 5 volts. Okay. Hopefully you understand that. If you don't, go back and review some of the earlier lessons. But guys, on this, don't just try to wing it. Just do the math every time, because every time it's going to be a little different. If you just think it's a line, get your 2 points, map it out, it's always going to work for you. It's a really good example of why you need to understand how to use a line very well, do the equation of a line very well. Okay, so let's get back now. We've sort of gone through the math, and again, I've got the schematic and I've got the summary of the math on our website, Top Tech Boy, and we are on lesson number 11 already. Okay, so you've got the schematic, and then you come down here and you can get a little graphic of the math if you need to go back and look at it a little bit more closely. But we've got the math, we've got the circuit built. I kind of went over the key points of the circuit. LED, long leg of the LED always needs to be pointing towards the voltage supply, and we're using a 330 ohm current limiting resistor. Okay, so we should be ready now to come in and start writing some code for this thing. So let's sort of kind of think about what we're going to need to do on this on this code. Well, the first thing is we're going to need to use some variables for our pins. And how many pins are we using? We're using 2 pins. We're using a pin that we're reading the potentiometer from, and we're using a pin that we're writing to the LED. So let's go ahead and make variables for those pins. And pins are always round numbers. And so let's say that we're going to do our LED pin. and you can name them whatever you want, but make sure that it's something that makes sense, and then also make sure that it's something that you know, that basically is descriptive of what you're doing. So LED pin, and I'm going to go ahead and set that to 9 because in the circuit and in the schematic I have that LED hooked up to pin 9. Remember, you want to use one of the pins in there that have the squiggly line by it, because we're in analog, right? You need to do one with a squiggly line by it. Okay, so we set that up, and basically we're saying declare LED pin to be Arduino pin 9. Okay, let's be good and put our comments in. Then we also are writing, or we're also reading the potentiometer, so we need to set up something. I'll call it pot pin for the potentiometer pin. And in the schematic and in here I have that connected to pin A0. That is a 0, that's not an O. If you put in an O, it will not work. So it's integer pot pin A0, and what we're doing is making a comment. Okay, declare declare the pot pin to be analog pin A0. Okay. Now, what else are we going to have to do? Well, we're going to have to read a value from the potentiometer, so I need a variable, I need a bucket to put that number in. So I need a variable or a bucket for the number that I'm going to read from the potentiometer. And so I'm just going to call that the read value. That's what I'm going to read from the potentiometer. I'm just declaring it. I don't have to set a value because I'll go get it. I'll go get that with a read later on. So I just declare it. I don't have to set it to a value. Use this variable to read potentiometer. Okay. Now, I also need a variable for the value that I'm going to write to the LED. So let me set that up. I'm going to have a write value. Okay. And this is going to be the variable for writing to LED. All right. I think that we can do that because we need our variables for our pins. We've done that. We need a variable to read into, and then a variable that we're going to use for the value that we're going to write. So I think that's in pretty good shape there. So let's go to our void setup. What do we need to do here? Well, if you look here, we're not really reading anything from the serial monitor. We're getting our number from the potentiometer this time. And we really wouldn't have to write anything, so really you wouldn't have to set up the serial monitor. But setting up the serial monitor is always useful because it helps you debug things. And I want to look and see what value I'm actually writing to the LED. And that way, if there's any trouble, I can go in and I can debug it pretty easily. So I usually go ahead and turn the serial port on, whether I think I'm going to need it or not. So I'll turn that on at 9600. Okay, and then we're going to turn on serial port is our comment. And then what do we do in the setup? We need to do our pin modes. Okay, our pin modes. We're going to have 2 pins, so we need 2 pin modes. Our pot pin is going to be a what? Well, we're reading from the pot pin, and so the pot pin is going to be an input. Remember, input, all caps. Okay. Set pot pin to be an input. Okay. Pin mode, and then our LED pin. We are writing to the LED pin, so what should it be? It should be an output. Remember that? Okay. Set LED pin to be an output. Okay. Now we pretty much got our, I think we've got our setup, void setup pretty good. Remember, the stuff you put in void setup is the stuff you're going to do one time. Then we come down here and we're going to do our loop, our void loop. Well, what is it we're going to be looping through? Well, we want to read a number from the potentiometer. Based on that, we want to calculate a number to write to the LED based on the equation that we used, and so then we want to do that, and then we want to write that to the LED. So there's basically going to be sort of 3 steps that we're going to want to do. We're going to want to read a value from the potentiometer, calculate a right value, and then write that right value to the LED. And so those are kind of the 3 things that we need to do in our void loop. So we start by reading. We want to read that value from the potentiometer. So our variable for that we called read value. And we're going to, where do we get read value? Well, we do an analog read. Okay, remember the command analog read? And if we're going to do an analog read, we have to tell it where we want to read. Well, we want to read pot pin, okay, because that's where the potentiometer is. So we read voltage from potentiometer, okay. Now, once we've read that value, we now want to calculate the number that we want to write to the LED, and that was all the math we did there. The right value is going to be equal to 255 divided by 1023, okay, times the what? Read value, okay. And go back and look in the other earlier video or on the website if you need to review how we got that. Now, this is something very, very important, and most of the time when I come around and look at students' work and it's not working, it's because they did exactly what I did here. 255, if you don't put a decimal point after 255, you are telling Arduino 255 the integer. Well, 255 the integer divided by 1023 the integer is the integer value 0. And so it's not intuitive, but you have to come in and you have to tell the Arduino that these are floating point numbers so that it will give you the in-between numbers. So you have to say it's 255 point. That's a floating point number. 1023 point. That's a floating point number. And that way you'll get 255 divided by 1023 is somewhere around a fourth, as opposed to 255, the integer, divided by 1023, the integer would come out to be 0. And so if you're getting strange behavior, make sure that you're going in and telling it that 255 is a float and 1023 is a float. So here we are calculate right value. Okay, so now that's the value that we want to put out onto the LED. So now what should we do? We should actually write it. And how do we write it? We write it with an analog write. And where do we write to? We write to LED pin. That's where we're going to write. And now we got to tell it, what do we write? What number do we write? We write the right value that we just calculated. Okay, so what's this doing? This is right to the LED. So we're writing our value to the LED. Now this, if we run, should work. Okay, but just to be careful, I always like to print out just so I sort of see what's going on and see what I'm printing. Make sure I didn't do anything that's going to surprise me. So I'm going to do a serial dot print. And what am I going to print? I'm going to print you are writing the value of, in a space. Okay, I did a serial print because I don't want to go to the next line, because here I want to say serial dot print, and this time I'll go to the next line of print line and I will say write value. Okay, so this is all going to be on one line. It's going to say you are writing the value of, it's going to print that string, and then on the same line, because I did a print on that same line, it's going to print the right value, the number that I'm writing to that pin. And I do that with a print line, so it'll go on to the next value. I'm thinking this is going to work, so let's go ahead and download this. Okay, look at that. We got a lot of green. Everybody is happy. The program is down in there. Let's look at the serial monitor. And if I look at the serial monitor, you see it's showing me that I'm printing a value of 69, and right, that would be a fairly low voltage. Okay, and so now if I turn this to the left, what should happen? The LED should get dimmer, and this number here should go down. And so as I turn this to the left, you can see the number going down, and you can see the LED getting dimmer, and if I go all the way to the left, you can see that it's off. So when I'm all the way to the left, I'm writing a value of 0, and that value of 0 corresponds to 0 being written here, and the LED is off. If I begin to turn the potentiometer to the right, I should start getting the LED coming on. Okay, and you can see there it's just barely on. I'm just barely writing a value to it, and then as I begin to turn it up, it gets brighter and brighter, and then when I get all the way to the right, I'm writing a value of 255, which corresponds to 5 volts, which puts the LED at full brightness. So I can go from full brightness down to a dim value, down to dim, barely on, dimming, all the way off. Okay, so we've done what we set out to do here, and what you can see now is this circuit behaves without the serial monitor. It behaves without the user inputting anything. It's like a little dimmer switch that as I begin to turn it up, it gets brighter, and as I turn it down, it gets dimmer, and I'm controlling the brightness of the LED from the potentiometer. And to do that, we've had to combine a lot of the different stuff that we've learned in all the earlier lessons, and now we've got something that does something pretty cool, I think. Okay, well, I've stepped you through this kind of like in little bitty baby steps, but using these same concepts, what your assignment for tomorrow is that go ahead and write the LED to full brightness. So just sit there and in your code make the LED full brightness. The goal is not to set the brightness. Now what I want you to do is to set the blink rate based on the position of the potentiometer. If the potentiometer is all the way to the left, I want it to blink very slowly. I want it to blink on for a second, off for a second, on for a second, off for a second. If you have it turned all the way to the right, I want it to blink really fast. So all the way to the right, I want it to be on for 1/100 of a second and off for 1/100 of a second. So what you have to do is you have to scale smoothly between those two values, between those two endpoints, that at the slowest, it's on for a second, off for a second. That's when the LED is all the way to the left. And then all the way to the right, I want it on for 1/100 of a second, off for 1/100 of a second. So that's 0.01 seconds on, 0.01 seconds off. So what are you going to have to do? You're going to have to get your chart out, and you're going to have to make a chart. Okay, and you're going to have to calculate that on time and off time by having a horizontal axis. Well, on your horizontal axis, you're still going to be going from 0 to 1023, but now on your vertical axis over here, you're going to be going from 1 second to 0.01. Now the interesting thing is, on this case, your y-intercept is not going to be 0, so you got to be a little bit more careful in your math, and your y-intercept is not going to be 0. So also you got to make sure to be very careful that you're doing floating point math, that you're telling it that those numbers are floating point. And so I'm going to leave that to you for your assignment, and I'll come around and look at it tomorrow. If you're taking this online, it's just up to you to do it on your own. If you have any questions, post it on my website. Thanks, guys. This has been exciting. We're going to be starting to really ramp up here and do some more interesting things. Look forward to seeing you again on lesson number 12 very shortly. Take it easy, guys.